Okay, so the next thing we want to do is to expand these ideas from kinematics into two dimensions, since so far we've only talked about one-dimensional motion. But before we get to that, we need to talk about vectors. And vectors are mathematical quantities that have both a magnitude and a direction. And in one of the first videos, I told you that position, velocity, and acceleration are all vector quantities. They all have a magnitude and they all have a direction. So in one dimension, that was pretty straightforward. The direction was either forward or backwards, or you could even say like positive or negative. So in two dimensions, it's a little bit more complicated, of course, because there are two axes the object can move along. A vector in two dimensions is described basically by two quantities, and you can think of it as describing a point on an xy graph. You need two values to describe that, the x value and the y value. So that's similar for a vector. I guess first of all, a vector is usually shown by drawing an arrow like this, and the vector is variable. In this case, I'm just calling it capital A as a general name for a vector. And to show that it is a vector, I draw an arrow above it. And the magnitude of that vector is given by the absolute value symbol. So that's A with the absolute value sign around it. And the direction is generally given by the angle it makes with a certain axis. In this case, I'm drawing it as the angle with the x-axis. But again, you can also describe this vector in coordinate form, where the components of this vector are a sub x and a sub y. In this case, we have a vector that has a magnitude of 10 meters and an angle of 30 degrees. So we can compute between the magnitude and the direction and the components by using trigonometry. So basically we can draw a triangle where the hypotenuse is the magnitude of the vector, and then the sides are ay and ax in this case. And we can just use our trig functions to compute between them. So in this case, that would mean that cosine of 30 degrees would be ax divided by the magnitude of a, because cosine uses the adjacent over the hypotenuse. So we can rearrange that to calculate the value of ax. In this case, that would be about 8.67 meters. We can do the same thing for ay. Ay will be equal to the magnitude of the vector times sine of 30. And when we calculate that, ay is approximately 5 meters. The vector a then we can also just write out as its components. That means a is equal to parentheses 8.67 comma 5 meters. So that would be like describing a point on a graph. So we can also add up vectors in a straightforward way. So what we're going to do here is take two vectors a and b and add them together to get the resulting vector c. And a is just going to be the same vector again, 8.67 comma 5 meters, and b will be this vector here, -1 comma 4 meters. And first of all, graphically we can add up these vectors by putting them tip to tail, and the resulting vector c starts at the beginning of the first vector and ends at the end of the second vector. And mathematically, all we do is add up the components. So the x component of c sub x, is equal to the x components of a and b added together. So in this case, that would be 8.67 minus 1, which is 7.67 meters. Similarly, cy is equal to the y components added together. That would be 5 plus 4, which is 9 meters. So the vector c then is 7.67 comma 9 meters. Subtraction can be done in a similar way. In this case, graphically, we have to flip the direction of the second vector and then treat it like addition. So the vector -b is just pointing exactly in the opposite direction as b was pointing. And then again, we can put the vectors tip to tail to find c. Mathematically, we just subtract the components. So c sub x then becomes 9.67 meters. cy is then 1 meter, and the resulting vector is 9.67 comma 1 meter.